A view of Earth from space is dominated by the blue of the oceans and the bright whiteness of clouds and ice. Earth is unique. Water in the liquid state does not appear to occur anywhere else in our solar system. For example, Venus is so hot that water exists only as vapor. The amount of water on Earth is immense, an estimated 1.36 billion cubic kilometers, 326 million cubic miles. Most of it is in the oceans. The remainder is distributed among ice sheets and glaciers, groundwater, lakes, streams, and the atmosphere. At the temperatures and pressures at Earth's surface, water occurs naturally in all three states of matter: solid, ice, liquid, water, and gas, water vapor, and readily changes from one state of matter to another. There are constant exchanges of water among the oceans, the atmosphere, and the continents. This unending circulation of Earth's water is called the hydrologic cycle, or simply the water cycle. Water enters the atmosphere by evaporation. More evaporates from the oceans than from the land. Eventually, water vapor condenses to form clouds, and precipitation returns liquid water to the surface. What paths does water follow once precipitation falls on the land? A portion soaks into the ground. Eventually, this water seeps into a stream, lake, or directly into the ocean. While the water is beneath the surface, it may dissolve soluble rock and produce caverns and other solution features. Water that does not soak in flows across the surface as runoff. Much of the water that soaks in or runs off eventually re-enters the atmosphere because of evaporation from soil, lakes, and streams. Some of the water that soaks in the ground is taken up by plants, which later release it back to the atmosphere as water vapor, a process called transpiration. Many factors influence the proportion of water that soaks in or runs off, indicate whether each of the above situations favors greater infiltration or greater runoff. When precipitation falls as snow at high elevations or high latitudes, it may become part of a snowfield or a glacier. Eventually, the ice melts and the water soaks in and runs off. While the water is locked up as glacial ice, it can move across the landscape and be a powerful erosional force. In the diagram above, notice that more water evaporates from the oceans than is returned to the ocean by precipitation. Just the opposite is true over land. Precipitation exceeds evaporation. If sea level is not falling, then runoff from the continents must balance the deficit of precipitation over the oceans. The erosional work accomplished by the 36,000 cubic kilometers, 8,640 cubic miles of water that annually flows from the land to the oceans is enormous. Stream erosion is the single most important agent sculpturing Earth's surface and is significant to the origin of many sedimentary rocks. The function of a stream is to drain water from the land. The land area that contributes water to a stream is its drainage basin. The drainage basin of one stream is separated from another by an imaginary line called a divide. North America's largest river, the Mississippi, has a huge drainage basin covering about 3 million square kilometers, nearly 1.2 million square miles. All drainage systems are made up of a network of streams, which together form particular patterns. Can you identify the correct name for each of these patterns? The ability of a stream to erode and transport material is directly related to the velocity of the water in the channel. Several factors influence stream velocity, including gradient refers to the slope of the stream channel. The steeper the slope or gradient, the faster the water moves. Gradient is typically expressed as the vertical drop of a stream over a certain distance. Calculate the average gradient of a river that originates 1,000 meters above sea level and flows 200 kilometers to the ocean. If this stream developed extensive meanders so that its length increased to 400 kilometers, what would its gradient be? Channel shape influences friction. These channels have the same cross-sectional area. Which has the least frictional drag? Click on the correct answer. All else being equal, water in a rough, boulder-filled channel should move faster or slower than water in a smooth channel. Click on the correct answer. Discharge is the amount of water flowing past a point in a given unit of time. It is usually expressed as cubic meters per second or cubic feet per second. Compute the discharge of a river 30 meters wide, with an average depth of 1.5 meters and an average velocity of 0.8 meter per second. The discharge of the Mississippi River places it 7th on the list of Earth's largest rivers. The average discharge of the Amazon River is 12 times greater than the Mississippi River because its drainage basin is much larger and much rainier. When discharge increases, as during a flood, how do channel width, channel depth, and velocity change? In order to handle more water, the stream erodes its channel deeper and wider. The larger channel is more efficient, less friction, and thus the velocity increases. When the cross-section of a typical stream, called the longitudinal profile, is examined, we see that the gradient is steeper or gentler near the head. Click on the correct answer. Because of the contribution of tributaries and groundwater, discharge should usually increase or decrease toward the mouth of a river. Click on the correct answer. Measurements show that stream velocity usually increases toward the mouth of a river. Which of these reasons might help explain the higher velocity near the mouth? Click on all that apply. Large quantities of water occur below the surface in the pores and cracks of soil, sediment, and rocks. Precipitation percolates downward to the water table. Below the water table, all pore spaces in the sediments and rocks are filled with water. This is called the zone of saturation, and the water here is called groundwater. The water table is rarely level. Instead, its shape is a subdued replica of the surface topography. That is, the water table is highest under hills and lowest in valleys. The height of the water table fluctuates. During droughts, it drops. And during wet periods, it rises. Above the water table, pore spaces are unsaturated and filled mainly with air. This is called the zone of aeration. The zone of aeration can be further divided into the zone of soil moisture, the intermediate belt, and the capillary fringe. Soil moisture extends downward to where plant roots end and is the zone that has the greatest variety and magnitude of biological activity. Some of the water in the capillary fringe moves upward in tiny thread-like passages between grains of soil or sediment. It is similar to what happens when a strip of paper towel is placed in water. Place each of the labels in the proper place on the diagram. Only about 0.6% of Earth's water is found underground. However, when the oceans are excluded and only sources of fresh water are considered, the importance of groundwater becomes more apparent. Obviously, the greatest volume of fresh water is locked up in glaciers. Since most glaciers are in remote places, they are not a major source of fresh water for people. After glaciers, the greatest volume of fresh water is found beneath the surface as groundwater. When ice is excluded and just liquid fresh water is considered, more than 94% is groundwater. Groundwater is a very important source of drinking water and water used for irrigation and industry. Groundwater has important geological roles as well. In humid regions, it contributes significantly to the flow of streams. In regions underlain by soluble rock, such as limestone, the dissolving action of groundwater creates sinkholes and caverns. The list above represents major sources of fresh water. Rank them from 1 to 5, with number 1 having the greatest amount and 5 having the smallest amount.
Let me tell you why we have Spectrum. I'm on a video chat. Melissa's live streaming with her audience. The kids are on their phone streaming while
The quantity of groundwater that can be stored depends on the porosity of the material. Porosity is the percentage of the total volume of rock or sediment that consists of pore spaces. Permeability is the ability of a material to transmit a fluid. If pore spaces are too small, surface tension keeps the water from moving. Larger pore spaces in well-sorted sandstone account for its high permeability. Rocks and sediments, such as shale and clay, have such tiny pore spaces that they are nearly impermeable. Such materials are called aquitards. Permeable rocks and sediments have larger interconnected pore spaces and transmit groundwater freely. Such materials are called aquifers. The presence of springs and the productivity of wells depends on the permeability and distribution of subsurface materials. Springs occur when the water table intersects Earth's surface and a natural flow of water occurs. Sometimes springs form when an aquitard is situated above the main water table so as to produce a perched water table. Wells, the most common method of obtaining groundwater, are holes that penetrate well below the water table into the zone of saturation. When water is withdrawn from a well, a depression in the water table may develop called a cone of depression. When pumping from a large well is great, the cone of depression can be large enough to influence neighboring wells. In some places, groundwater is being mined. That is, it is being withdrawn far more rapidly than it can be recharged. When the water table is lowered in areas underlain by unconsolidated sediments, significant ground subsidence may occur. Some places have artesian wells. Artesian applies to any situation in which groundwater under pressure rises on its own above the level of the aquifer. For an artesian system to exist, water must be confined to an aquifer that is inclined so that one end can receive water. And aquatards must be present above and below the aquifer. When an artesian aquifer is tapped, the pressure created by the weight of the water above will cause the water to rise. For each question, click on the correct well in the diagram.